Hmm. That was weird. So the live stream crashed and it said live streaming is not available right now. So let me know if this is working. Okay, it says it's live. All right. We'll believe it then. Here you go, Chad. And this one. Okay. Okay. Well, then I guess it's working. Oh, wish what? Glad I get to fall asleep to you. Yeah, live. So I can adapt. Yeah, I can go like, wake up, and wake you back up again if I need to. You might want to play something that isn't live. Otherwise, yeah, I'm just gonna mess with you. Okay. Let me just go live. Recording reminder. Yes, I am recording. One a.m. Is this for the people in Australia, or is this for the night owls? Is that what this is for? Okay. Casey, you've asked this question before. Would astronauts still do land and water survival training if the T-38 wasn't also part of the training? I have no idea. The the Crew Dragon lands in the water, so they definitely have to do water training. But theoretically, it can. So they announced last year that there was another option to do a landing with the Crew Dragon. But you can imagine it goes off course, happens to land on land, and they have to be able to do land training for that as well. Okay. I think we're all working now. Okay, so for those of you wondering what it is that you've stumbled into, this is going to be the live question show. So this is the raw material, the grist for the mill that gets turned into the question shows that we publish every week. So I will be your host for the next 2 hours while you pepper me with questions, and then I will be able to hopefully answer them. So a couple of ground rules, which I would like to say. First thing is that I try to give emphasis to the people who've never had a question answered before. So if this is the first time you've ever done this, I like your chances. I'll be looking out for names that have never asked a question before. The second thing is just keep in mind that I am not a scientist. I am just a journalist. So I cannot provide you any additional information above and beyond the scientific consensus. I am just a conduit, a way for the scientists to share their consensus with you. I have no original opinions when it comes to science. And then third is I'm sort of editing the show as we go. And so I'm thinking about whether or not I know the answers to questions. I'm thinking about if I've gotten this question many times before. And so if I'm not answering your question, it's nothing personal. And also we get about 3 to 4 times, no, about 3 times as many questions as I have time to answer, depending on how long-winded I am. So it's nothing personal. Just ask your question once, and I will be able to, hopefully, be able to get to as many of the questions as I can. All right. It's always personal. You have opinions. I have opinions. I can't provide you opinions on scientific questions. So, Owen Bowen, how can a black hole be used to generate power? So there are a couple of ways that black holes are theorized that they can use power. The first way is that you feed material to the black hole, and that will, most of the material will go into the black hole, but you will also get high energy radiation coming off the black hole. You get gamma radiation. So theoretically, if you put like a mini Dyson sphere around your black hole, you will be able to capture the energy that is coming off the black hole. And really, it's just like as matter is falling into the black hole, as matter is going into an accretion disk around the black hole, there's lots of ways that black holes can release high energy radiation, X-ray radiation, gamma radiation, and so you could theoretically harness that. But the most efficient way to harness power or energy from the black hole is known as the Penrose process, and this was a clever idea thought up by Penrose, where you drop material into the black hole, and then the material will some of it will go in and some of it will be kicked out. So say you drop a cannonball into a black hole, and just as the cannonball is about to go into the black hole, you hit it at just the right angle. Then part of it goes in and part of it then gets a kick, almost like a slingshot, back out. And then you can capture the kinetic energy of this material that wasn't consumed by the black hole. And then you can use that to power your starships or whatever. And I forget the exact number. I think it's 38% efficient. So the most efficient process you can get to get energy is matter and antimatter. So if you have matter, you have antimatter, you put them together, it is 100% efficiency. You can gather all of the stored E equals mc squared between the matter and the antimatter as you put it together. With the Penrose process, it's 38% efficient. So it is extremely efficient compared to almost every other form of energy that we possibly know of. And there's like a third way, and I forget what it is. I'll try to remember, or maybe do a follow-on of what, because there was like a paper that came out a year ago, 2 years ago, that we reported on, and somebody had come up with a novel additional way that you could harness the energy from a black hole. Snar's tax. Have you looked at the timescape cosmological model? What do you think of it? So I always give this disclaimer at the beginning of every live stream that I do, which is that I am a journalist, not a scientist. I don't have opinions about these kinds of things. I have done some reporting on the timescape model. It's been a couple of years now, but the gist is that astronomers consider the large-scale structure of the universe to be largely homogeneous, that no matter where you go randomly in the universe, the amount of material that's around you is going to be roughly the same, like to 1 part in 30,000, if I remember correctly. So, it doesn't matter where you go, everything is going to be roughly the same. Now, sometimes you will be at the center of a star or the center of a planet, but most of the time you won't be. Most of the time you will be in intergalactic space, you'll be in interstellar space, you'll be out there in the cosmos, and things are going to look kind of the same. But a team of astronomers have proposed that homogeneity is not true. That in fact, when you go into the larger, more dense regions of the universe, the places where you have, galaxies, galaxy clusters, galaxy walls, the sort of large scale collections of galaxies, then those parts of the universe are actually going to be significantly denser than the voids and other parts of the universe. And if so, then you're going to get different amounts of time dilation between the places which don't have a lot of mass and the places that do have more mass. Think about how, when you get close, think about the movie Interstellar, right? When you get close to the black hole, then you experience time dilation because you're in the presence of a large mass. Now, it's going to be subtle, but over the course of billions of years, those differences add up. And that explains dark energy. It's not that we are seeing the universe accelerate over time, the expansion of the universe accelerate over time. It's that we are seeing parts of the universe that are experiencing time at different rates. And that, according to them, they do the math, it fits better for the explanation of dark energy than this idea that, in fact, there's some intrinsic nature of the universe that is accelerating its expansion. And recently, dark energy has been sort of turned upside down. When dark energy was first, when the accelerating expansion of the universe was first discovered in 1998, astronomers weren't looking for this. This was an accident. They were trying to calculate how the expansion of the universe was going to slow down over time. It's assumed, right? That all this mass, there was the Big Bang, everything's moving away from itself, but eventually, right, the mutual gravity of everything is going to slow it all down, and eventually it will come to a stop. And they maybe even collapse in on itself. And astronomers are trying to figure out, what is that point? Will it expand forever? Will it coast to a halt at an infinite amount of time, or will it actually start to collapse in on itself and lead to the big crunch? And what they found when they measured the sort of the changing expansion rate of the universe over time was that it seems to be accelerating. And again, that was a surprise. Nobody asked for this, right? This is not a fudge. This is not a theory. They went into it with no expectation that there was going to be this weird result, and yet there it was. And the more supernovae that astronomers detected, the more of these that they found, the more this idea was confirmed. And so whenever you have a mystery like that, you figure out what is the best way to study it to answer these questions. And so we got the DESI survey, the dark energy spectroscope instrument, the dark energy survey instrument, and then we got the Euclid mission, we got Vera Rubin, we've got all of these, we've got Nancy Grace Roman coming up. Like, all of these instruments, their job is to measure the universe at different times in its past in different ways. And then we can get this really good idea, this really precise information about what the universe was doing at different phases. But the first one to release its results from DESI found that the universe appears to be, that the amount of dark energy is changing over time. That instead of it being this sort of smooth addition of dark energy into the universe at set amounts of time, that maybe it's actually changing as well, decreasing over time, which is kind of good news because, one of the big concerns, like, what if dark energy is increasing? That's how we get the big rip. So if dark energy is decreasing over time, then eventually maybe it'll just go away. And so when the Timescapes model was released, it sort of was well timed with the DESI survey first result, and they felt that their explanation was a better answer, fit the math better, fit the observations better. But we are just in early days of this. And so, until we get this proper answer from Euclid, from Vera Rubin, from Nancy Grace Roman, from DESI, for years and years and years and years, it's all still too early days to have any kind of definitive answer. They think the math works. Other people think the math doesn't work. It's too early to tell. Bradley Fitzik. Why does Avi Loeb keep calling this an alien mothership? I have no idea what the motivations are of people who are calling Comet 3I Atlas anything but a comet. It's possible that they genuinely are looking at it and looking at its size, because it is surprisingly big, and it is moving surprisingly fast. That this is by far the fastest interstellar object that we've seen coming through the solar system. They're looking at the fact that it's going to be hidden from the Earth when it hits its closest point to the sun. That's weird. It's going to be doing relatively close flybys of Mars, the sun, and Jupiter. That's interesting. So those are things that are interesting coincidences. But then there are other things that are just totally comet-like. It's grown a comet. It has grown a coma. It has grown a tail. It is moving exactly as you expect an object that is bound to, or it's moving exactly how you would expect an object that is moving through the solar system, interacting with the gravity of the sun to behave and move. Hasn't done anything weird. So, on the charitable side, and there are lots of channels here on YouTube that are doing a lot of speculation about this. On the charitable side, they, something in this they find compelling, and they're sort of running with their hypotheses. And on the uncharitable side, they know that this kind of thing is very exciting, and that a lot of people want information, and we want to know about aliens, and is this the one that tells us the aliens? And so there's a certain amount of playing to that audience. So far, all the reporting that I've done on this, and like we have reported on it week after week after week, and it's mostly, here's some pretty pictures. It's a boring comet. Look at these cool pictures. Here's some ideas on how we could send a spacecraft to it. We'll continue until it is out of sight. And then we'll wait for the next interstellar object. And then we'll observe that one too. And it will do exactly normal, boring comet-like things, because that's just how it works. And it would be amazing if it was aliens. Like, that would be the greatest thing ever. I can't wait to be wrong. But if I am wrong, I want to know for sure that I'm wrong, not have a slight hint, maybe copium, that I'm wrong. Oh, that's a good question. In Visigoth, if a 10-pound meteorite landed in your yard, would you keep it, sell it, or give it away? So I have a meteorite right there. It's a 1-pound meteorite, not a 10-pound meteorite. So if a 10-pound meteorite landed in my yard, would I keep it, sell it, or give it away? I would contact scientists. So I would, and I'm specially equipped to be able to make contact with the scientific community. I would reach out to planetary scientists and say, a 10-pound meteorite just landed in my yard. It's fresh. What would you like done with it? And probably it is put it in a bag and stick it in your freezer right away. Whenever there are fresh meteorite falls, they're very exciting and very useful. They're very scientifically interesting, because these things have been out in space, possibly since the very beginning of the solar system. They've been orbiting around and around, and they have just entered the Earth's atmosphere for the first time and landed on the ground. And so they're still fresh from space, and they haven't been colonized by Earth bacteria yet. They haven't been weathered down. They haven't had some of their minerals replaced with things on the surface of the Earth. And so whenever there is a meteorite that has a chance of surviving to the surface, then scientists will do big surveys to try and find them. There was one that landed here in Canada a couple of years ago that it happened in the wintertime, and people calculated that it was going to hit a lake. And so they were able to go out and get it while it was completely cold out. They were able to pull it out of the ice, and they were able to put it into cold storage. So that's what I would do. I would quickly take it, stick it in the freezer, and then I would contact planetary scientists and let them know what I've got. Arab 99. Hey, Fraser, fellow British Columbian here. So with all the cuts, has the idea of sending a probe to Sedna been scrapped? Well, there was never a approved mission to Sedna. So there was a paper that proposed that you could send a mission to Sedna, and that now would be a very good time to go to Sedna because it's going to be making its way back out into the outer solar system. But nobody has actually approved that mission, planned that mission, assigned budget to that mission. It is just somebody had a good idea and like sketched out what the mission would be like. Jay Garrick. Fraser, what plans are in the works to capture a sample from an interstellar object? Wouldn't that be amazing if we could get a sample from an interstellar object? I mean, we have all these questions about how do other star systems form? Do they have the same kinds of chemical composition as we have here in the solar system? Or do they have something totally different? And we just don't know the answer to that. Like, how could we know? Well, we could know because the universe is throwing samples of different star systems at us, and all we have to do is catch them. And so as soon as the first interstellar object, Oumuamua, was discovered, people were proposing different kinds of missions that could try to chase it down and study it up close. And then people started to think about, well, if there's going to be future missions coming through the solar system, could we somehow intercept one? And so missions have been proposed, designed to intercept comets and interstellar objects. The European Space Agency has gotten the furthest along with this. They've designed and were planning on launching a mission called the Comet Interceptor in 2028 as part of the Ariel mission. So it would be sort of like a small spacecraft that would fly with Ariel. And then it would go out to the Earth-Sun L2 Lagrange point, which is sort of like a balancing place of gravity, and then it would wait for a target. And then when a target came into the solar system, either an interstellar object or some kind of long period comet, then it would perform an interception and fly past it and take a bunch of images as it flew past. So that would be like a first step. But as you said, the thing we really want is we want to bring a sample home. And so we've done sample return missions from comets in the past. The Stardust mission flew through the tail of a comet and then brought that material back home to Earth, and scientists have been studying it to this day. So you would probably do something like that, which is that you would send something like Stardust. It would hover out at the the L2 Lagrange point, wait for a target to show up, and then do a flyby and pass through the tail, but then follow a trajectory that brings it back to Earth so it can deliver its payload, and then scientists can study that. Now, there have been sort of even more elaborate ideas that would require some kind of exotic forms of propulsion. So one idea is that you could just take an RTG, a radioisotope thermoelectric generator, like a decaying chunk of plutonium, and it is producing heat, and then you would just bolt it onto an ion engine. So the ion engine is then producing the thrust. It would be very little to this spacecraft, and it would be able to accelerate quick enough to be able to catch up with an interstellar object, and then deploy a probe, and then maybe even be able to bring a sample back home to Earth. So it would be a tremendous engineering challenge for us to be able to do this. But if we did, it would be so much easier to collect samples of other star systems from interstellar objects than it would be to try to actually go to other star systems and collect samples directly. So for the next few centuries, the best chance we have of studying other star systems is from interstellar objects. Let's climb. If you could build a Dyson sphere, would you really need a Dyson sphere? It seems we would have figured out scarcity by then. The whole idea of a Dyson sphere is purely just a thought experiment, which is that if you were some advanced civilization, then you wanted to use up all, you kept needing more energy, then eventually you would be harnessing all of the energy that was coming from your star. And if you were going to be harnessing all the energy that was coming from your star, what would that look like, right? It would look like a sphere of satellites that are buzzing around your star, that are overlapping, and they're catching every photon that is coming out of the star. But that is not necessarily the most efficient or effective thing that you could do. You could take your star and you could do stellar lifting on the material. You fire lasers at the poles of the star, and that causes streams, jets to come out of the tops of the star. And then you collect this material, and now you've got hydrogen. You can turn this hydrogen into energy using fusion in a way that's much more efficient than what the sun does. So, I don't think it's necessarily about scarcity, although it could very well be, right? We could reach this point in our future evolution where we go, that's enough energy. We don't want to use any more power. We're now much more efficient, and there's no need to use any more energy. Of course, that is always a possibility, right? It's not a thing that humanity has done in its million years of history, but it is theoretically a thing that we could do in the future. But also, there are plenty of other way more efficient ways that we could use the material in the sun or in Jupiter or whatever to power our devices, right? That we would be able to use fusion energy. We would be able to use fusion energy instead of, collecting the sunlight coming off of the sun. So it's just a thought experiment. Don't put too much sort of, predictive power into the Dyson sphere. There's a great video that just came out from Angela Collier about Dyson spheres, and she quite accurately shows that Freeman Dyson probably was joking, was probably sort of pranking, trolling people who were talking about SETI. So definitely check out her video. I'll put a link in the show notes. You can check that out. Michael Boulos. If the universe is infinite in size, does that necessarily mean that every possibility, no matter how unlikely, including an exact duplicate of you living on a planet called Earth, exists elsewhere? So, right. So this is the idea that there are a finite number of configurations that matter and energy can take in a volume of space. That if you take a cubic meter of space, there's a finite number of ways that you can have sort of quantum configurations in that cubic meter. I forget the number. It's like 10 to the power of 80 or something like that. So it's a large number, but it is a finite number. And in an infinite universe, then finite numbers do very weird things, because you can essentially have, a finite number repeat an infinite number of times in an infinite universe. And so if you go far enough, like say you take one just chunk of space, 1 cubic meter of space, and measure all of the quantum states of everything inside that cubic meter of space. And then you go some giant distance, you'll see lots of different cubic meters of space, but eventually you'll find a repeat. It's kind of inevitable of something. And then you go farther and you find repeats of larger than just 1 meter, 2 meters, 10 meters, 1,000 meters, 1,000 kilometers. And so theoretically, not only will there be a repeat of Earth, of me giving a live stream on this other Earth, there will be a repeat of the entire Milky Way. There will be a repeat of the entire observable universe, right? Infinity gets pretty weird when you think about it. So, we don't know if we live in an infinite universe or a finite universe. That's still sort of one of the outstanding questions that astronomers have. But if it isn't an infinite universe in space, then the things can get pretty weird. And you can have an infinite universe in time, right? Into the far, far future that we know that quantum states can change over, in unpredictable ways. Mostly they will act in, the atoms will be where you're expecting them to be, but every now and then they'll be somewhere where they're not expecting to be. And if you wait long enough, then larger and larger numbers of atoms will rearrange themselves in ways that are new configurations. And so you can not only imagine those repeat cubic meters in space, but you can imagine those repeat cubic meters coming up in an infinite amount of time. So, if you have an infinite time in the future, sorry, if you have an infinite time in the future or an infinite space, then you can have weird repetitions show up. Now, the key here always is it has to be something that's possible. So you can't have things that are impossible, right? So you can have, we look around this world, look at the things that we see. Those are things that are possible because they happen once. But you won't necessarily be able to get magic, right? If it's a thing that's impossible, then you won't get that. You'll just get things that are possible. Lee Marinus, how does one tell if a comet has a tail if it's coming straight at the Earth? Well, everything is following an orbit. And so there isn't an orbit that is going to come straight at the Earth, that you're always going to be seeing the comet from different angles as it is moving through the solar system. And the Earth is moving in its direction, and you're going to be able to see the comet and see the tail. And also, we have other spacecraft in other places. We have spacecraft at Mars. We have spacecraft at Jupiter. We have spacecraft at Venus, although not anymore. We have a spacecraft going to Mercury. We have spacecraft approaching the sun. We have spacecraft at many different points around the solar system. And so you can look at the comet from different angles. James Webb Space Telescope, Hubble's by Earth, but James Webb's a little off away from Earth. So, you can get a different perspective. New Horizons, way out at Pluto, past Pluto, could take a look. So we've got lots of eyes in the solar system now. Sorry, just looking at the questions. Michaela Soul Speed, why does the space community focus so much on Alpha Centauri when Tau Ceti is also close to us and has 9, maybe 10 planets? Why not care more about Tau? So I'm not aware of Tau Ceti having any planets. Unconfirmed, unconfirmed, dubious, unconfirmed. Okay. It's just 11, 10. Okay. So, I mean, Tau Ceti is just shy of 12 light years away from us compared to just over 4 light years for Alpha Centauri. So Alpha Centauri is much, much closer, right? It is the closest bright star in the sky. Of course, Proxima Centauri is even closer. And so Tau Ceti is further. Once you get out to 10 light years away from us, there's about 100 stars within that volume of space. So, instead of just Tau Ceti, there's a whole bunch of other stars that you could think about as well. Most of them are red dwarfs, but still. Now, I'm not familiar with all of those planets. From what I know, there are 4 unconfirmed dubious planet possibilities, but nobody has been able to confirm them. So, all of the close by stars are targets of continuous exploration by planet hunters. So you'll see a lot of emphasis because these things are close. And so if you're able to find planet orbiting around a star that is only 12 light years away from us compared to finding planets that are 1,000 light years away from us, you've got a much better chance to be able to study it once you actually are able to look at it. Damien Reloaded. If the universe is infinite, does that mean that the Big Bang contained infinite matter? Sounds fishy. So the important thing to understand is that the Big Bang is a process where the universe is becoming less dense over time. That right now, when we look out into the universe, we see galaxies moving away from us. The universe is becoming less dense. And if you sort of look back in time, then those galaxies were closer together. And eventually, those galaxies were right on top of each other, that they were all in the same area. But the universe, if the universe is infinite today, the universe was infinite before the Big Bang, before this process of rapid expansion and sort of decreasing density. That there wasn't this point where you had an infinite amount of universe packed into a finite little ball. So instead, like you have to think either in terms of the observable universe or the entire universe. So when we think about it in terms of the observable universe, right? You look out in all directions, you see this giant sphere, and that's the stuff that the light has been able to travel to your eyeballs. That is what you can observe. And at the very beginning of the universe, what is now a sphere 93 billion light years across was once the size of a grapefruit, or was once the size of, something even small, a marble, very small. And then it became less dense over time. But right beside that grapefruit of our observable universe, or more specifically, my observable universe, which is different from your observable universe, there was another one right beside it. And that was somebody else's observable universe. And that is now a 93 billion light year across sphere containing all of the material that light has been able to reach this person's eyeballs. And there's an overlapping, right? Our observable universes can overlap a bit. So it's not that the entire infinite universe was compressed into a small space. It was still infinite, even before this process of becoming less dense over time. Whatever set the Big Bang in motion, there was still an infinite universe beforehand, and then an infinite universe afterwards. So don't think that you had to go somehow compress infinity into a finite space. Stony Fish, how dangerous would it be to let asteroid YR24 crash into the moon? What's the likelihood that large pieces of the moon or asteroid could break off and cause destruction here on Earth? So the danger of letting asteroid YR4 crash into the moon is that you're going to get debris. You're going to get a bunch of small particles get kicked up from the impact. And those particles are going to make their way down to the Earth, and they will be seen as a meteor shower, a meteor storm here on Earth. They're not going to be very big. They will be sand-sized. They will be, a few millimeters across at the most. Some larger rocks, but mostly they'll be very, very small. The issue is that satellites are moving at 10-ish, well, they're moving at, say, thousands, the problem is that satellites are moving at tens of thousands of kilometers per hour in orbit around the Earth. And so when something is moving tens of thousands of kilometers per hour and it strikes even a tiny little rock, it can cause damage to it. And so if there's like a ton of rocks and debris in the area and all our satellites are going to be moving through this debris field, then there's the potential for a lot of damage. And so we're going to lose weather satellites and GPS satellites and communication satellites and Starlinks and all that kind of stuff. It's just Hubble Space Telescopes, International Space Stations, right? Like, we don't know exactly what the damage will be, but the question is, if it just happens, maybe this could be a problem. And so that's why people are starting to think about, is there some way we can mitigate it crashing into the moon? And so if you go out and you break it up before it actually hits the moon, then instead of you getting one big 60-meter impactor hitting the moon, you get 10-meter impactors over a larger area, and they don't kick up as much debris than a big 60-meter one does. So that's the idea, and that's the risk that people are looking to potentially mitigate. Hello, Bucko. Jenny A., what is your daily routine gathering information and keeping yourself up to date in science? Are there certain magazines, forums, subscriptions, or contacts that you find reliable? Do you have a team collecting the information? So the way Universe Today works is that I am the main person for finding the stories that we're reporting about. And this is a task that I've been doing for 26 years. Which is that I go through all of my sources every day. And then if I find anything that I think is something that we should be reporting on, then I will pass it along to the team. And I have a ton of sources. I think I've got about 1,000 places that I can potentially look. Now, they don't all update every day, and so it's some subset. I use an RSS reader. I use Feedly to sort of gather all of the sources together. And what Feedly does that's really nice for me is that it lets me turn web pages into feeds so that I can check for any updates on them. And so I have feeds for, all of the space agencies, all of the journals, all of the universities that have significant space science research, all of the conferences that are going on, all of my competitors, everyone else who's reporting on space news, Reddit, Twitter, Blue Sky, all of the sort of places where people are talking about space, forums, as you said, newspapers. And so that's sort of the process that I go through every day. It takes me about an hour or so to just go through and evaluate all of the stuff that's breaking for the day and to put that into a form that then the writers can write from. And then it makes their job very easy. The writers are able to write whatever they want, whenever they want. It's up to them. But it sure is handy if Fraser has put a bunch of stories that are really compelling into this bucket, and all they have to do is just go in and grab a story out of that bucket. And, I have a certain perspective that I'm really interested in. And so the stories on Universe Today, because I'm sort of the one who's found the news in the first place, they very much reflect my personality. for good or for bad. So the kinds of stories that we're reporting on. And then that process, that thing that I do every day, then becomes the beginning of the rest of the reporting that we do. So when I'm seeing these interesting stories, if one feels like it's going to make a good interview, I will, in addition to handing the story off to a writer, I will reach out to the researcher and say, can I interview you on the YouTube channel? I will write up my description of the story, and then that gets turned into the newsletter at the end of the week. And then also all of the stuff that we do on Space Bites comes from all of the stories that we're reporting on Universe Today. So, we've been doing this so long and very efficiently at this point that it's sort of this holistic soup to nuts process. But it starts with me sitting down every single day for about an hour and just getting a sense of the lay of the land. What's all the stuff that's happening? What's the chatter? And then from that, we continue our reporting for the week. Tim P, what's the latest update on Planet 9? Could you please interview somebody about it? I need my Planet 9 fix. There's no update. The update is we need to wait for Vera Rubin. That is the machine that is going to find Planet 9. And so we're still about a month away from it going into its full operations, or 2 months away. Anyway, and when it does, then if Planet 9 is out there, Vera Rubin will be the one to find it. So at this point, the update is Vera Rubin is almost online, and it will also find millions of comets and asteroids and supernovae and weird stuff that the universe was doing when we weren't looking. But hopefully it will also find Planet 9. Okay. Levi Rivers. Scientists are worried about supernovae, and the closest, most dangerous stars never note Sirius B or Sirius A. If they go nova, would it be more massive than the sun and have a shorter lifespan, being about 8 light years away? So Sirius is a brighter star. It's about twice as massive as the sun, and it is about 8 light years away, so it's very close. Sirius B, I think, is a white dwarf. So not yeah. So Sirius B is a white dwarf star, so it is not going to be a danger. And even Sirius A, even at twice the mass of the sun, it is not in danger of going supernova. You need something to be more like 8 times the mass of the sun before you can get the sort of smallest possible supernova to go off. We don't know of any stars that are likely to go supernova within the sort of dangerous distance of us, which is about 25 light years away. We know of stars like Betelgeuse, which is 600-ish light years away, but we don't know of anything that's going to be that close. So Sirius, when it dies, which will be, it's going to live a shorter life than the sun will, it will turn into a white dwarf, just like the sun will. Dorimo 10, have the outer prospective planets had their hydrostatic equilibrium assessed yet? I don't really understand the question. It doesn't take a very large object to reach hydrostatic equilibrium. Just a few hundred kilometers across will get you hydrostatic equilibrium. And so, all of the dwarf planets, I think Haumea is a little oblong, but still has some level of hydrostatic equilibrium. Snars Tax. In the last year, James Webb studied Andromeda pretty extensively. Have they found anything interesting? I can't think of any interesting results out of Andromeda that come to mind. I kind of remember us reporting on something, but nothing really crazy out of Andromeda that I can think of. Sid Vicious. Starship 10's launch featured a long, weird speech by Elon Musk about Mars. Mars sucks. We know that. Why does Musk think we can go there so soon? Is it for the investors? I mean, I don't know what is in Elon Musk's mind. If you sort of go back to the beginning of when he became enthusiastic about space, his enthusiasm for space was inspired by the same book that mine was, and in fact, the same book that Jeff Bezos was, which was The Case for Mars by Robert Zubrin. I read that book 30 years ago, 28 years ago. And he laid out in sort of gripping detail why, a really clever idea for how you could send a mission to Mars and be able to come back, that you would live off the land, that you would send a spacecraft to Mars, and either you would find water on Mars to then use sunlight to use electrolysis to break up the water into hydrogen and oxygen, and then you would liquefy them, and then you would be able to you'd use the Sabatier process to turn carbon dioxide from the atmosphere of Mars and hydrogen into methane, and you could use that as your rocket fuel. And then you could land on Mars. You would send one spacecraft to Mars. It would land on Mars. It would start to generate fuel on the surface of Mars, and once it had finished, then another spacecraft would arrive. The astronauts would get into, they go out and they'd explore the surface of Mars, and they get into the one that had already been preparing for the return journey, and they would fly back home to Earth. And if you watch The Martian, that was the idea in The Martian. So if you remember, Mark Watney, he had to get to this other site on Mars because that's where the return rocket was being refueled. And so he was able to arrive, and, I don't want to spoil the movie, but that's what happened. So that idea, when Robert Zubrin proposed that idea in the book, it was like a, truly original idea that came out of nowhere, that we were all sort of hearing plans for Mars all the way back from, Wernher von Braun to the original Bush administration had proposed a mission to Mars, and it ended up being called the Battlestar Galactica. It's going to be like a $500 billion mission. And Zubrin was saying, no, you could do it for about $10 billion. That for the price of less than the price of the Apollo mission, you could send humans to Mars and bring them home again. And it was, it was an exciting idea. And I think that, a lot of people, myself included, had this very kind of science fiction infused idealistic idea of what it would be like to go and live on Mars. And then over time, I don't know what's happened to Jeff Bezos and Elon Musk. They went off and became billionaires. I didn't. But you just think about it some more, and you kind of go, well, wait a minute, right? Like, there's no money to be made. There's no reason to go, no reason to live on Mars, beyond the exploration. And that was the whole for Elon Musk. He had originally tried to he wanted to show how Mars would be really exciting. He wanted to drop a greenhouse on Mars and then have a camera showing the greenhouse growing on Mars. And he went and tried to get the Russians help, and they laughed at him. And eventually he said, well, I'm just going to build my own rocket company. And to be able to do this. And that was sort of the driving vision behind SpaceX. And, here we are today, and now SpaceX is the dominant launch company in the world. They're working on a fully reusable 2-stage rocket. There's all these plans. But the heart of it, this, we're going to go and send people to Mars, to live on Mars, to build a city on Mars, has, I think the consensus among most people is that is an extremely ambitious idea. An idea that is far more ambitious than just we need to build a rocket that can take people to Mars. There's like so many moving parts that anyone who actually goes to Mars is going to have to struggle for their daily existence, for their daily survival. And they're going to need constant resupply coming from Earth to be able to just not die on Mars. And then you're like, well, it's like, why do you want to live on Mars? I think for a lot of people, they have this sort of adventurous spirit about it. But I think we've seen plenty of examples where people think it's going to be an adventure in the beginning. There's tons of why I'm no longer homesteading videos on YouTube. And that's just like it in a nutshell. Like people are like, we're going to live off the land and we're going to raise our own chickens and it's going to be great. And then after a while, a year later, like, this is hard. I don't like it. I want to go live someplace where I can have community and go to the library and meet with people, and you get perspective. And I think that right now we're all in this sort of many people are in this really enthusiastic phase. The vision sounds great. The reality will probably be a lot harder and a lot weirder and a lot tougher and a lot more expensive than anybody's anticipating. Except for Bob Zubrin still is convinced. So I don't know what Musk's actual intentions are. It doesn't really matter, right? Like, the question is, what are his actions? That's the thing you have to watch. What are the actions of SpaceX? What are they doing? What are the actions of Blue Origin? What are they doing? So don't judge these companies based on some poorly described future possible plan. Just watch what they do and consider the impact that it's having on the world right now, right? SpaceX is the dominant launch platform. SpaceX is launching a constellation of tens of thousands of internet communication satellites. Blue Origin is building a rocket, its own partially reusable rocket system. They're flying space tourists. They're doing things. Like, it's not, nothing is happening, but it's still a long shot away from a city on Mars. So, I think, I think a lot of people got quite excited by billionaires saying that they wanted to send humans to Mars. Like, that's great. Like, finally, right? Finally, we have to wait for the government. Finally, someone's going to show up and they're going to put their own money where their mouth is and they're going to do it and they're going to pull it off. But there's this sort of bubbling frustration that is growing, that what's taking so long, right? And what's taking so long is that reality is revealing itself, that this task is monumentally harder than anybody is expecting, for very little payoff. No payoff, apart from the scientific fascination of us putting boots on Mars and being able to examine some rocks and search for some water, maybe search for some life. Like, there's a lot of really interesting scientific questions that can be answered on Mars. There's not a lot of value in people living on Mars, right? Much less value than people living at homesteading in the middle of the Arizona desert. So I think that as we sort of look into the future, people who are really enthusiastic and excited will eventually just get frustrated because it's just taking too long. And who knows what the final long game is? Because, I always say that humanity's exploration, conquering of the solar system is inevitable. It's going to happen. It's the time frame, right? Like, if you think it's going to happen, like, there are probably people watching right now who saw Neil Armstrong set foot on the moon over 50 years ago. And if you're in the chat right now, give me a shout out. You watched humanity send a rocket to the moon and land safely on the surface of the moon and 2 astronauts stepped out and walked around on the moon and jumped around on the moon, and then they got back in their spacecraft and they came home, and then they did it 5 more times. 12 people walked on the surface of the moon. And when you were watching this, you probably thought, okay, this is it. It's 2001, right? We're a space odyssey. Like, we are now a solar system spanning civilization. It's just, we got to fill in the details, but there'll be cities on Mars, because this is what happens next. And actually what happens next is that the mission was wrapped up, and then nobody set foot on the moon for 60 years. That there were some astronauts that flew in space, and eventually there was an international space station that had people on board. But it took a long time. And that's where we are today. And it's not because people don't want us to go farther. It's not that people aren't excited and enthusiastic about space exploration. It's extremely expensive. And the people who pay the bills have, only so much stomach to withstand it. And so again, back to that excitement when a billionaire shows up and goes, don't worry about it, I got this. I'm a billionaire. I can afford a few tens of billions of dollars to pay for a human mission to Mars. People are like, right on. And they've got a rocket company to be part of it. Yeah, do it. But even they are having trouble pulling this off because it is complicated and expensive. It's going to take a long time. So, 200 years from now, there will be people across the solar system. 50 years from now, I would be surprised if there's anything more than a couple of human missions to Mars. There you go. Paul in Tucson. I was in my parents' family room. Todd Ablett watched it in black and white cabinet TV in Terrace, BC. Yeah, that's awesome. MJ, I was 8 years old. Yeah, and so tell me, like, when you watch this, or by the time the Apollo 17 mission came back, it was a couple more years later, I'm sure you must have felt like this is it. Like, we're gonna live that science fiction future. It's gonna be Star Trek next week. It's gonna be Star Trek tomorrow. And it turns out it was harder than we thought. And it turns out nobody wanted to keep spending that kind of money on it. So, yeah. So I have no idea. I have no idea what's in the minds of the billionaires. All I know is that it's going to be a very difficult, complicated, challenging, grueling, money gobbling endeavor that very few have the stomach for. And there's no upside. There's no reward at the end where you can cash it all in. Eugenio Bevilacqua. What about Gliese 710 passing within 0.22 light years away from the solar system in the next 1.49 million years? Those are some very specific numbers, and I believe you're right, but I'm not going to double check them. I know that the Gliese star is going to come within a quarter of a light year in the next million years or so. So, I will confirm what you said there. So these are great. And, because, people have used Gaia, all hail the Gaia mission, to measure the trajectories and motions of various stars in the universe, and realize that stars have made close flybys of the solar system in the past, and are going to make close flybys of the solar system in the future. And 0.22 light years away is very, very close. We would be able to see that star as it was passing within the solar system. It's still way beyond the Kuiper belt. But it is relatively close compared to the nearest star. And there's a really great idea, which, we think about how this idea of how von Neumann probes, right? In the far, far future, will build self-replicating robot probes, and they'll go to other star systems, and then they'll replicate themselves at other star systems. And people always say, well, the distances between stars are too great that, 4 light years might as well be forever. And it turns out that you can wait, and you don't have to wait, if you wait 1.49 million years, then you're going to get a star coming within 0.2 light years of us. But if you're willing to wait 5 million years, you're willing to wait 10 million years, you're willing to wait 1 billion years, you're going to get stars that are going to come even closer. And so there was like this calculation that someone had made saying, okay, well, what if you just wait? What if instead of you trying to jump to every other star system, no matter what the distance is, you instead wait for every star to have close flybys of other star systems? It only increases the amount of time that you need to take by a few million years. That if it's going to take you 10 million years traveling at 10% the speed of light to colonize the entire Milky Way, or if it's going to take you 10 million years, no, 1 million years. Yeah, it's going to take you 1 million years to go to every single star system in the entire Milky Way, going at 10% the speed of light, and you decide you want to wait for stars to get close to each other, it only adds another like million years to the calculation, or 2 million years. That you just wait for, your von Neumann probe goes to a star system and then waits for close flybys, and then it does to the near star system, and you get the same outcome with a dramatically lower amount of fuel use and time and energy and expenditure. So it makes the Fermi paradox even weirder. Where are all the aliens? Where are all the aliens that waited for stars to get close to each other? Where are all the aliens that used rogue planets to hop from star to star along these islands of additional, these gas stations along the way? Daniel Verburn. Do you think there is some chance for M dwarf stars to host habitable worlds? So, not an astronomer, journalist, but I have asked this exact question to astronomers. And the answer that we get is they don't look great. They look like very bad stars. If you wanted to have a habitable world next to an M dwarf star, the problem is, these red dwarf stars, they have these terrible flares. They have flares as powerful as the sun, more powerful than the sun. And the planets have to be very close to the star to be able to receive some of the sunlight and to be in the warm habitable zone. As and the planets are tidally locked to their stars. So they're facing one side, the habitable side of the planet is always facing at the star, facing the flares. The flares are hitting. And every single simulation and calculation that astronomers make show that these close-up planets are going to have their atmospheres stripped away within a few 100 million years early on, not long enough. They won't be able to survive long enough to be able to have thicker atmospheres form, protect life, go on to have a habitable world. If you can get past that first billion years or so in the age of a red dwarf star, then the star settles down, and then it actually is a great place to be for a long, long time. But you got to be able to survive that really bad early billion years. But other simulations show that once you get far enough away, say in the TRAPPIST-1 system, that, the first 4 planets are going to be bombarded by radiation. But maybe at the 5th planet, things look good. The 6th planet, things are starting to be okay, right? The 7th planet is outside the habitable zone again. So you have this really tiny little zone. But, let's drink some water. But red dwarf stars are the only stars that we can study right now. That James Webb does not have a coronagraph that's good enough to be able to see Earth-sized worlds orbiting around sun-like stars. It can only see Earth-sized worlds orbiting around red dwarf stars. And so those are the stars that astronomers are looking at, because that's what's possible right now. And many astronomers, if you came to astronomers, 10 years, from the future, astronomer from the future comes back and says, all right, well, we looked at every single red dwarf planet that we could, and none of them had atmospheres. Today astronomer, you would go, yeah, that sounds feasible to me. That sounds right. It was a long shot, but we were hoping. But maybe the future astronomer comes back and says, like, the universe once again did something we were not expecting, and that for some reason planets around red dwarf stars have figured out a way to have thick atmospheres, and they seem to be in the habitable zone, and there could be life there. And we even detected a biosignature. And today astronomer will go, yeah, that sounds reasonable to me. I'm not surprised. So right now we're in this in-between state that James Webb has tried to observe atmospheres around several planets orbiting around red dwarf stars within the habitable zone. I don't know if my voice is going to hold up tonight. James Webb has examined several red dwarf stars and their planets in the habitable zone, and so far, no atmospheres for any of them. But we can't rule it out forever. Yeah, I'm losing my voice. Sorry to do this. Let me see if it gets any worse. I'm gonna have to call it because I can start feeling my voice giving. Yeah, tea. Scotch. Okay. Matthew Moore, is there anything on the dark side of the moon? Well, this is the part where the will actually people will show up and say, well, actually there isn't a dark side of the moon. There's the near side of the moon and there's the far side of the moon. But that's not entirely true. There is a dark side of the moon, right? Half of the moon is in shadow. Half of the moon is in sunlight. And so the part of the moon that is in shadow is in the dark side. And the part that is in sunlight is in the light side. Is there anything there? Yes. When we have a new moon, we are seeing the dark side of the moon. When we see a full moon, the dark side of the moon is on the other side of the moon. But for the far side of the moon, yes. Now, the moon is tidally locked to the Earth, and so we always see the same size. The moon is tidally locked to the Earth, so we always see the same side of the moon all the time. And so it wasn't until the space age that we actually could finally get pictures to see what it looked like on the far side of the moon. And when you are familiar with the near side of the moon, you sort of, there's some craters, but there's also these big sort of dark gray areas, the mare, which we know are old lava flows. On the far side of the moon, it's just pounded by craters. You don't have those old lava flows. So it's a very weird and unusual looking surface. And very surprising. That was not what people were expecting. They were expecting the far side was going to look kind of like the near side, but actually looks totally different. And that is one of the big unsolved questions: is why is the far side of the moon so different from the near side? There's some theories at this point of why, that maybe there was like another moon that broke up on the far, rained down on the far side, that the interior structure of the moon is kind of lopsided. And so we got more volcanic activity on the near side than we did on the far side. So still a bit of a mystery. But yeah, look at pictures of the far side of the moon. It's very weird. Darren Green, if there are people on the moon or Mars at nighttime, are they safe from solar storms? Yes. Yeah, the issue of a solar storm is that you are, there is a flare or a coronal mass ejection. There's some kind of event that is coming off of the sun and is streaming away from the sun. And you are then having these accelerated protons and other heavier elements going into your body and you are taking radiation damage from it. And the way you prevent that is that you put some mass in between you and the solar storm. And the best way to do that is to put the entire moon in between you and the solar storm, or the entire Mars between you and the solar storm. Now, that's only one of the kinds of radiation you have to worry about. The other kind of radiation is cosmic radiation, which is coming all the time from all directions. And it's actually the more dangerous kind of radiation. But like a solar storm that can kill you in a day is dangerous. But normally the radiation coming from the sun isn't deadly in the way that a solar storm is. And the solar storms, if they actually happen to hit you, are fairly rare. You know, your chances of getting hit by a solar storm are low. But if you're on the moon and a solar storm is inbound, and it turns out you're going to be at night on the moon when the solar storm hits, then you're fine because you've got the whole moon in between you and the solar storm. But if the solar storm is going to hit during the day, then you're not fine, and you better go and dig a hole and hide. Lister Bear, where are we with the space telescope using the star pattern to see other solar system planets? So I think what you're talking about is the star shade, which is this idea of a satellite that will float separately from, say, the Habitable Worlds Observatory, and to be able to observe planets, Earth-like planets around other stars. And what it'll do is the star shade will directly block the light of the star, and then it'll have these petals, and then the planet will be sort of just outside of where the petals are, and the shape of the petals sort of causes the light to be blocked better. Where are we at with this right now? We're waiting for people to actually plan out and begin funding the Habitable Worlds Observatory. And right now, the current White House administration is cutting funding to future space missions. And that's one of the missions that's on the chopping block. So where are we? We're nowhere is where we are. We're nowhere. Check again in a decade. Redhead Roach, would astronauts at the South Pole be always protected from solar storms, or always vulnerable? Yeah, it depends. If you're in the shadow, then you're protected. And if you're in the sunlight, then you are vulnerable. Ravensmoreland. If a spaceship launched with a balloon that was a meter bigger than the ship, could it collect water from the plumes of Enceladus to freeze around your ship for radiation protection? So I don't know. I mean, I don't think you could collect enough water from Enceladus to be able to actually form a shell around your spacecraft. But water is a great idea. Like, if you can get your hands on water and form it in a shell around your spacecraft, then you will be protected from space radiation. You just need a meter of water in a bubble around your spaceship. If you have that, then you're protected from the radiation. But I don't know whether like trying to collect it coming out of Enceladus is going to be the right way to do it. You're going to want to sort of launch with your water. And what's great about water is you need it for other things. It's for drinking. You can use it for breathing, break it up into hydrogen and oxygen, use it for fuel. There's a lot of good reasons to keep water with you. It's also very heavy. So it uses a lot of propulsion to try and accelerate water. But once you, say, have a base on a world, you can totally form water into a shell above you. It's transparent, right? It's like a window. And it's protecting you from radiation. Gerganescu George, if the moon is not more advantageous to colonize than Mars, it's closer and we can send help in case of need. Yeah, I think the moon is perfect. We're so fortunate that we have this large moon relatively close to the Earth that we can use as a place to practice our space exploration. That all of the things that we're going to need to do to be able to survive on Mars, we will be able to practice most of those on the moon. And the moon is harsher. The moon is a tougher environment to survive on than Mars is. And so if we can live there, we can live anywhere. And that's why, but it's very close, as you said. And so if we send a bunch of explorers, if we set up a base on the moon and they run into problems, we can send them supplies. We can, if they really run into problems, we can rescue them. We can bring them home. We can send more astronauts up to help them out. So that's a place to test out all of your ideas, to find out what breaks, what fails. What do you need more of? Do you need more toilet paper? What's it going to take? Because once you send humans to Mars, they're on their own. There is no help can arrive for them. It takes you 9 months to a year to be able to send a rescue mission to Mars. Yeah, Arjun, the moon is the New York of space. Yeah, if you can make it there, you can make it anywhere. Tom's Cubes and Games. What is your least favorite Lagrange point? That's interesting. People always ask me what my favorite one is. I would say it is the Earth-Moon L3 Lagrange point. That is my least favorite. That is the one that is on the far side of the Earth from the moon, and there's kind of nothing out there. There's no moon out there. The only advantage you get by being out there is that your view to the moon is blocked. If you needed to make some kind of observation where you couldn't see the moon, maybe that's where you'd want to use the Earth-Moon L3 point. But apart from that, I can't think of any reason. So it is truly useless. But now I say that, and I'm sure somebody will think of a really clever use for the L3 Lagrange point. Sonarsax, do you know when Atlas will be closest to Earth? October 26th? Let me see. It's going to be 0.36 AU from Earth. No, 1 AU from Earth. And the date, it's like late October. No, December 19th. Okay. So October 3rd, it has its closest approach to Mars. October 29th, it has its... That's right, I'm thinking perihelion. Okay, so October 29th has its closest approach to the sun. And then November 3rd, closest approach to Venus. And then December 19th, closest approach to Earth. And then March 2026, closest approach to Jupiter. And the closest by far is the approach to Mars at 0.19 AU, which is pretty close. Mark Oz. Fraser, what do you think is the most realistic date for humans to land on Mars? I imagine 2040 to 2050 is the most realistic, optimistic range, but no space fan likes this time frame. Yeah, I think 2040 to 2050 is realistic. That sounds about right. There are currently no concrete plans to send humans to Mars. Like, I know Elon Musk says humans are going to go to Mars any day now. but there are no concrete plans to send humans to Mars. The Chinese are gearing up to do their exploration of the moon by 2030. They're going to probably spend the 2030s exploring the moon, and then they'll probably feel like they have the skills to send a mission to Mars. So in the 2040 to 2050, let's say between 2040 and 2060, we will see the first human set foot on Mars. 2060, I'll be 89? No. Yeah. Hopefully I'll see this. I'll live long enough to see the first human set foot on Mars. In Visigoth, could we make a new planet if we push enough asteroids close enough together? If we pushed all the asteroids together, we would make a planet with 5% the mass of the moon. So if you think that's a planet, I don't. It's a big asteroid. Darth X. Oh. Are there any upcoming missions to park near Earth asteroids rather than deflect them? No. Nope. Trying to park an asteroid is really hard. They're very massive. Think about how much chemical rockets it takes to move, how much propellant it takes to move chemical rockets. To try to move an asteroid is ridiculous. So, there was a plan back in the Obama administration where they were thinking maybe they could try to capture a small asteroid and put it into orbit around the Earth, and then they could use that to try and, study it. And it didn't go anywhere. People have thought about that for space mining as well, but it's an asteroid. It's very heavy. We can barely land on an asteroid. You think about Hayabusa 1 wasn't successful. The Rosetta mission trying to land on a comet, the Philae lander didn't work properly. You got a successful landing with Hayabusa 2 and with OSIRIS-REx, but still, that's the very limit, is it just barely kiss an asteroid and take a few bits of dirt away from it. But to drill into an asteroid and fire your engines and move that asteroid. But if you watch For All Mankind, they do it, and it's a pretty cool adventure plot, part of the story. So, but no, there are no plans to park an Earth asteroid. There are papers. People have thought about this idea, but nobody is actually planning to do this. Johnny, if the solar system is moving fast through space and the gravity of the sun is pulling rather than pushing away, how is the Oort cloud even a sphere? Why doesn't everything ahead of the motion get overtaken? It's all moving with us, right? The sun is moving through the Milky Way. The planets are orbiting around the sun as the sun is going through the Milky Way. The Oort cloud is this cloud of comets that is moving with the sun around the Milky Way. It's all tied together. So it's not if the Oort cloud was separate from the sun and they, then they would come apart. But because it's all just moving together, it's you're on a boat and the boat is moving through the ocean. Why don't you just fly off the back of the boat? Well, because you are moving, in this case, the friction of your feet touching the boat and the boat, and you are moving at the same velocity. And so you're not falling off the back of the boat. Think about when you're in an airplane, right? Why don't you fly out the back of the airplane? Because you are sitting in the seat, you are moving the same speed as the airplane through the air, and your motion is tied with it together. Those aren't great analogies. Um, church discography. Has extraterrestrial lightning been observed yet? On Jupiter, but not on Venus. I think people thought they saw lightning on Venus, but it hasn't been confirmed. But lightning on Jupiter. And lightning on Mars in the dust storms? Now I'm not sure. So probably not on Mars. And theoretically on Venus, but not seen. So Jupiter is the one. Yes. So there are images of lightning on Jupiter captured by the Juno mission. So the only place that we know of for sure where there is lightning outside of Earth is on Jupiter. On Saturn, yeah, probably on Saturn and Uranus and Neptune too. Oh, and people are saying also on Titan. Let me just confirm. Now I'm getting Titan builds for Path of Exile. Oh, there's a story on Universe Today from 2008, but I'm not seeing definite confirmation of lightning on. No evidence of lightning has been observed on Titan. So no lightning on Titan. Jupiter, probably Saturn, Uranus, Neptune. One, if we're seeing into the past, has anyone modeled what the universe looks like right now? Not really. There's kind of no point. We're what the universe looks like right now, right? The Milky Way. That we can look over, we see Andromeda, we see other nearby galaxies that are just a few, say, tens of millions of light years away. We're seeing them tens of millions of years into the past. That is what the universe looks like right now, roughly. Now it's going to be different wherever you go. It's going to be, there's going to be bigger galaxies, smaller galaxies, different, separations from each other. They're going to have more stars, less stars, bigger black holes, smaller black holes, but roughly things are going to look kind of the same. That what we see around us is sort of the story that you're going to see everywhere that you go. It's the wonderful thing about astronomy is that you can look into the past, that you can use your telescope. It's a time machine, and that we can look into these times that are no longer around us. And yet, if we look far enough away, we can see these times in the past. I always say that archaeologists would love to have the ability that astronomers have, that they can see into the past. Archaeologists can't do that, right? They have to look at the clues they see around them to try and get some sense of what happened in the past. Astronomers just look. They just look through the telescope and they see the past doing what it was doing in the past. Driving in Luton. Do you think aliens are using Earth as a reality TV show along the lines of Squid Game? They take bets on whether we blow ourselves up this year. Well, keep in mind that depending on how far away the aliens are, they're seeing Earth in the past. And so, some aliens, maybe if they're just 4 light years away from us in Alpha Centauri, they're seeing us as we were 4 years ago, and they just saw us get, come down with coronavirus. But, and then the people who are at Tau Ceti, right? 12 light years away, they're seeing Earth 12 years in the past. what's that? 2012. They're seeing us freaking out about whether or not the Earth is going to end in 2012, and that we have been broadcasting into the universe for about 100 years now with our radio. So they're listening to old radio dramas mostly right now. So they're not even really thinking about where we're at right now, currently. Oops. Okay. Sorry, just looking. Potato Biden, how can capitalism exist in space? I mean, the way capitalism exists in everything, which is that people think they can make money from it. And so they invest in some endeavor and then they see a profit and then they reinvest that profit into it and then they keep growing their company. So, I mean, obviously we have telecommunication satellites, Starlinks, right? So people are making money from putting things in space. We have weather satellites. We have Earth imaging satellites. Right now, our entire space economy is focused on supplying services to the surface of planet Earth from space. But that's the beginning. And then you can imagine some future where somebody is able to make a profit on mining an asteroid. And then suddenly you've got a whole new, mining in space will work like mining on Earth happens. Now, it's going to take a long time, right? Like right now, the cost, is a huge money losing gamble, but maybe in the far, far future, someone will figure out or have enough infrastructure that it does make sense to do space mining. Maybe, you mine your resources and you send them to fuel depots, not back to Earth. But still, you can imagine somebody coming up with a business model that will then continue on into the future. Oh, and you're saying, won't AI make capitalism obsolete? Well, I mean, AI will make, if AI is going to make capitalism obsolete, it's going to make a lot of things obsolete. It's going to make humanity obsolete, right? Like the worst case scenario is the AI kills us. The best case scenario is that the AI disempowers us, right? That we get the Wall-E future, where we're a bunch of blobs that don't have the ability to critically think anymore. We don't know how to make money. We outsource every decision that we make to an AI, and we all have AIs at our disposal that we use to wreak havoc upon our enemies. So, like, that's the best case scenario. I'm not super bullish on what's going to happen with humanity and AI. Dermo 10, any prospective NASA missions or projects you want to advocate for? I mean, we're at a funny time where like 30, 40 missions are potentially on the chopping block right now. And so the missions that I want to advocate for are all of them, especially the ones that are still functioning completely and doing really good science. And that all you need to do is just keep the lights on and have a skeleton team that's continuing to gather data that is not very expensive. And yet, we're going to lose access to the Juno spacecraft to Jupiter, New Horizons, which is out in the Kuiper Belt, the Maven spacecraft at Mars. We're going to lose a whole bunch of Earth observing satellites that are telling us what is the state of the climate. All this is going to be a disaster for science. So I would advocate for not shutting down operational missions. That's what I would suggest. And then there's all the missions that were potentially in the works. I mean, I know that the planning for the Mars sample return mission has gone way over budget, but people have proposed ways to bring that budget back down. We should totally do that. NASA should totally do that. That the scientific community would like nothing more than to get their hands on the samples collected by the Perseverance rover. There are chunks of Mars, very carefully chosen pieces of Mars waiting to be brought home that would be a treasure trove of knowledge and information about Mars, about the search for life on Mars, about the geologic history, about the history of water on Mars. All we need is them to bring those samples back home. And that, like, every day that goes by that we don't have those in our hands is a day that we don't get the answers to all of those questions. So that, and then there's the Habitable Worlds Observatory. Like, I want to be able to find other Earths. There's a ton, but right now, like, we're in survival mode now. Like, just don't cut all the missions, please. Sam B, could space be part of war strategies in the future? I mean, it already is, right? Like, there is Space Force. There's already a part of the U.S. military that is concerned about space warfare. Now, again, like communication satellites, like weather satellites, they're directing this back at Earth, right? Which is like, how do you destroy enemy satellites? How do you protect your satellites from being destroyed by aircraft launching missiles at them? So that's what people are focused at right now. But you can imagine that you'll start to try to, the satellites will have to maneuver away from each other, have countermeasures to be able to stop rockets from hitting them. And it becomes more and more complicated. And eventually, we've got Space Marines. That's how that probably works. Tim P, have we seen any Carrington-like events since the actual Carrington event, but pointed in the opposite direction from the Earth? Yes. We have seen events that are more powerful than the Carrington event, just not pointed at Earth. So we know the sun is continuing to do this on a regular basis. We just have been lucky so far that one hasn't been directed at us. Todd Ablett, which comes first? Oh, which was the first commercially successful moon base or commercially successful? So, which would be the first commercially successful? I'm trying to think of your question here. Which comes first? All right. Which comes first? A commercially successful moon base or a commercially successful space station? I think we'll have a commercially successful space station first before we have a moon base. There are a couple of commercial space stations in the works right now that we should see launching within the next couple of years. We've seen some commercial, private, tourist flights. And so you can imagine that millionaires and billionaires are going to want to go to a private space station and float around in space for a week. And they'd be willing to pay tens of millions of dollars to do it. Setting up a base on the moon is going to be really hard. That is going to take some of the best, most knowledgeable people to be able to do that. And then there will be commercial entities that will try to do that as well afterwards. Maybe, or maybe the commercial people will come first. I don't really know. But right now, I think anticipate a space station that the billionaires can go play in first before you see a base on the moon that the billionaires can go play in. Who will think of the billionaires? Yes. 1,000 dots. If someone made organic von Neumann probes, will we just mistake that for panspermia? So the idea of von Neumann probes, these are self-replicating robot probes that go from star system to star system. Panspermia is this idea that life spreads from world to world within the star system through asteroid impacts. So, like, is bacteria an organic von Neumann probe already that nobody made? Like, it just is happening, right? That, if you take bacteria and you hit it on Earth with an asteroid, it can fly to space and survive, and then it can handle being in interplanetary space for a few centuries, and then it crashes back down onto the surface of some other world, and then it can survive that, and then it can go on to propagate. So, nobody had to design it. It just already has the capability to do that. And that you could then extend that idea that, if the Earth is shedding life, and when Gliese 740 comes within 0.22 light years of us, maybe some of that life will reach Gliese and spread. And then maybe that's how life spreads from star system to star system. It could be that we find, we eventually, 1,000 years from now, we get to a nearby star system and we find there's life there, and we find that it has a common ancestor that we do, and that we can actually trace that there was another planet where life came from before life got to the Earth and Alpha Centauri. So, there's lots of, we report on papers from time to time where people propose different ways, different methods of interstellar panspermia. So that idea working within the solar system could very much work from star to star. You have to explain how life can survive hibernating inside a comet for 10 million years. But if that's possible, or if there's water inside the comet and it stays liquid and life can stay alive for a while, who knows what's possible. Angela G. Forte. Is there any news on the New Horizons mission regarding any more bodies that will come close to? There is no news. I actually was scheduled to interview Alan Stern about New Horizons and sort of what its prospects are. We had to cancel the interview for a couple of months. He was busy with something. So, but hopefully as soon as he's back in his time, we will do the interview. And I'm going to ask him that exact question, which is, tell me about the new potential worlds that New Horizons can find. But we're really just waiting on Vera Rubin, right? Vera Rubin, within a few months of operation, will probably turn up potential future targets for New Horizons. There's no other telescope that can do it with the sort of quantity that Vera Rubin is going to be able to do. So all of these sort of future, where's Planet 9? Where do we find more interstellar objects? When are we going to find 1 million Type 1a supernova? The answer is Vera Rubin. All answers come from Vera Rubin. All hail Vera Rubin. Moon Trustee, we need to figure out better self-sustaining spaceships before we can colonize other celestial bodies. Yeah, and before we can do that, we need to run experiments like the Biosphere 2. We need to get really good at closed loop environments. And this is just a thing that we're not studying as much as we should. We don't look like if SpaceX was serious about building a city on Mars, they would have a city on Earth that was simulating a city on Mars to find out every way that it's going to go wrong. Matthew Brown, what is the largest moon in the solar system and how does it compare in size to Pluto? The largest moon in the solar system is Ganymede, and I don't know. Let's see, I'll let Wolfram Alpha tell me the Ganymede divided by Pluto. Let's see what it tells me. Oh, I have to do radius of Ganymede divided by radius of Pluto. Wow. So Ganymede is 2.2 times bigger than Pluto. Ganymede's really big. I wouldn't have thought it was that much. Slugs. Since NASA is now a spy agency, does that mean that it's now up to private companies to explore space? No, it's up to the Chinese and the European Space Agency to explore space. But NASA still is going to be exploring space. They're not a spy agency. I've heard this sort of it described this way. But no, NASA is still dedicated to science and space exploration. That Space Force is the spy agency that has the reconnaissance satellites that are observing the ground. So, if NASA does get gutted, then the United States will just no longer be a key player in space exploration. That you will look to the Chinese, you'll look to the Europeans for future space missions. One, can you imagine the Chinese landing on the moon? Sure. The Chinese are testing their new heavy lift Long March rocket right now, and they are testing. They just recently tested their lunar lander component. They did a drop test and a full fire of its engine, and that all seemed to go well. So they've got the is it Lan Yue? Anyway, they've got the sort of in 2030 they're going to send 2 rockets to the moon. One rocket is going to carry the crew capsule, and then the other rocket is going to carry the lander. And then the lander and the crew capsule will meet up in lunar orbit. They'll dock, and then the crew will get into the lunar lander while the capsule remains up in orbit. The lander will go down to the surface of the moon, and then they'll get out and they'll do a bunch of science on the moon, and they'll get back into their lander, and then the ascent module will pop off the top of the lunar lander, go up and meet with the capsule in space. They'll get back into their capsule, and then they'll return to Earth. So it's very similar to the Apollo mission, except instead of it all being in one big rocket like they did with the Saturn V, it's going to be on 2 heavy lift rockets that will meet up at the moon, which is a pretty elegant solution for the problem. And at this point seems like a more elegant solution than the SpaceX solution, which is to send 15 to 20 starships to refuel in space and then go out to the moon and then use a starship as a lunar lander, which is supposed to happen in like 2 years now at this point. So, it's not. It's going to be delayed. Certus what is the strongest motivator for humanity to attempt an interstellar probe with a camera, or other than the possibility of us going extinct? Because we're curious. We want to see what another star system looks like up close. So that's the motivator, not about us potentially going extinct. Right? Like, I want to see what another star system looks like up close. Wondering Fool, have the Chinese decided on where they're landing on the moon? No, not yet. Wolfgang, could L3 could be used as some sort of space station or fueling area? Yeah, I guess so. But remember that everything is orbits. So why would you want to be at L3 when you would prefer to be over on the side with the moon? And L2, where James Webb and all of the other spacecraft are. Why would you want to be at L3? Looks like you have the answer to the Pluto smaller than the moon. Jay Sarvin, what do you think 3i Atlas is? Say it with me. It's a comet. Piznops, can you see satellites at night with the naked eye? Yes. If you have dark skies, you can see tons of satellites just with your eyes. Ostsan, would a modern day Carrington event not be as destructive because electronics are more resilient instead of being glass shards of electrolytes and iron rods stuck in the ground? Nope. It would be very destructive because, it's all about jamming electrons through wires. That's the telegraph poles caught on fire in the Carrington event. And so imagine all of the telegraph poles that we currently have in all of our modern electronics, all of the transmission lines, all of the internet lines, all of the circuitry, all of the routers, the entire internet, all of the satellites, all of the wiring, everything has the potential to be fried. And so you're going to get, if an entire electrical grid can't suffer one big transmission line going down, and it's inevitable. So, a Carrington event would sort of short circuit or overload wires across our entire electrical grid. Very bad. All of the satellites will go offline. Electronics stop working. Cars will stop working. We don't know. Not everything is going to stop working. Some things will be great and totally resilient and handle it no problem. But, we already know that our electrical grid is creaky at best. And so it does not need the insult of an enormous surge of electrons moving through it. All right. We have reached the end of our show. It's midnight here, Pacific Standard Time. It's 3 a.m. for you maniacs, Eastern Standard Time, or Eastern Daylight Time. And I don't know what Australians. What time is it there for you guys? Hopefully, it's like 5. Is that right? Let me see. Time in Sydney. I bet it's 4. No, it's 5. Okay, great. There we go. All right. Thanks, everybody. Give a thanks to the moderator, who is Arjone today. Thanks to Arjone. And also our greatest question asker. What have we got going on? We got an amazing interview coming today, or tomorrow, about a different idea for a telescope. So you're really going to enjoy that one. I've got other big interviews planned coming up this week, so it's going to be another busy week. Yeah. Thanks in advance, Chad, Anton. You're going to have to edit this nonsense as usual. And we will see all of you next week at Pacific Daylight Time next week. All right. Thanks, everyone. See you later.